In this set of questions, we're going to be looking at the orbital motion of the planets. So, question 1. At inferior conjunction, an inferior planet is 0.28 astronomical units from Earth. Because it's the inferior conjunction, this means that the planet is orbiting between the Sun and the Earth. How far away is the planet from Earth when it's at superior conjunction? So when the planet is here. Well, to know that, we need to work out the distance between the Sun and the planet. Now we know that this distance here from Earth to the Sun is 1 astronomical unit. So therefore the distance between the planet and the Sun must be 1 minus 0.28, which is 0.72 astronomical units. We therefore know that the corresponding distance on the other side will also be 0.72 astronomical units. So when the planet is at superior conjunction, it's going to be this distance here from the Earth to the Sun, which is 1, plus the distance from the Sun to the planet, which is 0.72. And doing 1 plus 0.72 gives us 1.72 astronomical units. Question 2. When Mercury is at superior conjunction, so this means that it's on the opposite side of the Sun to the Earth, so over here, and where is the Earth? Would be here, so this is Earth, and this is Mercury. It is 1.38 astronomical units from Earth. How far from the Earth is Mercury when it is at inferior conjunction? So when it's at this location over here. Well, again, we can start to work things out. So we know, for example, that this distance here must be 0.38 astronomical units, because the total distance 1.38 minus the distance away between the Sun and the Earth, which is 1 astronomical unit. So we now want to know this distance. How far is it from Earth? Well, we know that the distance from the planet Mercury to the Sun is 0.38 astronomical units, because we worked that out here, and we know that the total distance is 1. So therefore, to work out this missing chunk here, we need to do the total distance 1 minus the distance to the Sun from the planet. So that will give us an answer of 0.62 astronomical units. When Venus is at superior conjunction, it is 1.72 astronomical units from Earth. How far is Venus from the Sun? So again, we can draw our diagram with Venus at superior conjunction. And we know that it is 1.72 astronomical units from Earth. So this distance between Earth and Venus is 1.72 astronomical units. And we want to know this distance, how far is it from the Sun? Well, nice and simply, we know that from the Sun to the Earth is 1.0 astronomical units. So therefore this distance here is the difference between 1.72 astronomical units and 1. So we'll do 1.72 astronomical units minus 1 astronomical unit to give us 0.72 astronomical units. The distance between Earth and Mercury when at inferior conjunction is 0.62 AU. What is the orbit radius of Mercury? So again, if we draw this, so it's an inferior conjunction, so we're on the same side as the Earth. So there's Mercury and there's Earth, so they'll be at these locations. It tells us the distance between the Earth and Mercury is 0.62 astronomical units, and we're trying to work out the distance between Mercury and the Sun. Again, we know that from the Earth to the Sun is 1 astronomical unit. So again, this distance here is going to be the total distance 1 minus the difference between the Earth and Mercury, 0.62 astronomical units, which will give us 0.38 astronomical units. Question 5. The mean orbit radius of Jupiter is 5.2 astronomical units. How far is Jupiter from the Earth when it is at opposition? So now we're dealing with Jupiter, we're dealing with a planet that is further from the Sun than the Earth is, and so there are some different terms that we would use. So opposition means that it is on the opposite side of the Sun from Earth. So it would look something like this. It tells us that the astronomical unit here is 5.2 astronomical units, and we want to work out this distance here. Well, again, we know this distance here is 1.0 astronomical units, distance from Earth to the Sun. So quite clearly this distance here is going to be 5.2 astronomical units, the distance from Jupiter to the Sun, minus the distance from Earth to the Sun, which is 1.0 astronomical units. So that will quite simply be 4.2 astronomical units. 6. When Neptune is at opposition, it's 29 astronomical units from the Earth. Let's just add our diagram here. So we've got the Earth and the Neptune. And so we know that this distance between Neptune and the Earth is 29 astronomical units. How far is Neptune from the Earth when it's occulted by the Sun? So this will be the point where the Sun passes in front. So Neptune must be over here at conjunction, the opposite side. So it's asking us how far is the distance when it's occulted by the Sun. So therefore, how can we work this out? So we need to know the distance between Neptune and the Earth, which would be this distance here. And we know that would be 29 astronomical units. But the Earth isn't in this location, it's over here. So again, we've got to add on these two distances here, which is simply the distance from the Sun to the Earth twice. So to work out the distance, it will be 29 astronomical units plus 1 astronomical unit and plus another astronomical unit for the two gaps between the Sun. So that in total would be 31 astronomical units. Again, these don't have to just be with planets. So an asteroid has a mean orbit radius of 2.7 astronomical units. So the asteroid is here at 2.7 astronomical units. How far is the asteroid from the Earth when it's at opposition? So if it's at opposition, that means that the Earth would be on the same side there. So the asteroid would be on the opposite side of the Sun than the Earth. So we know therefore the distance between the Earth and the Sun is 1 astronomical unit here to here. So what's left must be 2.7 minus 1, which is 1.7 astronomical units. And finally, how many kilometers is the asteroid above from the Earth when at opposition? So it was 1.7 astronomical units, and we need to convert this into kilometers. So we need to know our conversion. So we know that 1 astronomical unit is the same as 1.5 times 10 to the 8 kilometers. What do we need to do to get from 1 to 1.7? We obviously need to multiply by 1.7. So we will do the same to this side. And if we work that out, we get 2.55 times 10 to the 8 kilometers.